According to the Stack Overflow Survey 2020, Python stands at the top of the list for the most desired programming language. Well, this does not come to us by any surprise, as we all know Python provides a huge set of libraries for various purposes. Well, one such library that we are going to use here is Kivy. Python Kivy is an open source framework that allows us to develop cross-platform multi-touch applications. So if you're someone who's looking forward to develop such kind of applications using Python, hi all, I'm Junaid here from Edureka, bringing you a whole new session on Python Kivy tutorial. So without any further delay, let's start off with today's agenda. We'll start this session by understanding what exactly is Python Kivy and its life cycle. Then we shall install Python Kivy framework on a system, followed by a simple demo application. We'll also learn about various types of widgets, UI elements, followed by a Kivy design language. Then we'll conclude this session by developing a Tic-Tac-Toe application and building its APK. So before we begin, do consider subscribing to our channel and hit the bell icon to stay updated on trending technologies. Also, if you're interested in taking up an online training certification in Python, check out the link given in the description box below. Starting off with what is Python Kivy. As I've mentioned earlier, Python Kivy is an open source framework that allows us to develop cross-platform and multi-touch applications. So now you might be wondering, right, what does cross-platform refers to? Well, cross-platform means having to write a single code for multiple operating systems. That being said, using Python Kivy, I can develop applications not only for mobile but also for desktop. Because of this, Python Kivy provides input support from various types of fields such as keyboard, mouse, multi-touch events, etc. A few of the features of Kivy is that it is fast as it is written in C language. The Kivy language encourages its developers to reuse the code, thus decreasing the code size and enhancing its readability. Lastly, Kivy ensures its developer easy development and deployment of applications. So now that we know what is Kivy, let us now have a look at its life cycle. The execution of Kivy application occurs only when the run method is called. This run method creates a platform called as window wherein we can insert our widgets. After a run method is called, it is the responsibility of a build method to initialize and combine various types of widgets and layouts that were defined. In the next stage of the Kivy lifecycle is the onStart method. The onStart method is an event handler which is executed after the build method but before running of the application. Once the application starts to run, it can encounter one of two stages. It can either be stopped or paused. If the application stops, onStop event handler will kill the application window. Meanwhile, if the application is paused, onPause event handler will rerun the application from start or terminate the application window. Now that we know how Kivy application runs in the background, let us now install Kivy library on a system. Assuming that you have already installed Python and Anaconda on your system, let us now create an Anaconda virtual environment within which we'll be setting up our Kivy library. To do that, I'll be moving to my Anaconda prompt. Now to create my virtual environment, I'll be typing conda create hyphen name followed by environment name. Here I would be giving as env underscore name underscore one. It can be anything, like you can define your environment name followed by Python version. Python version that I would like to use here is 3.7, but you can use any Python version. Just make sure you're using Python 3 and then hit enter. As you can see that we have successfully created our virtual environment. Now to install our Python library or framework to our Anaconda, we are supposed to activate it. To do that, we'll be doing conda activate followed by our environment name. So here, like it's env underscore name underscore one. I'll just hit enter after that. You'll see that we have changed our virtual environment from base to our own virtual environment. Now to install Kivy on a system, we need to write just one line of code. But before we install Kivy, right, let us see if we have Python Kivy pre-installed. To do that, we'll jump to our Python shell, Python, and then hit enter. So here we are at Python shell. Let us now import Kivy, import Kivy. Hit enter. So you can see that we get this error, module not found, right? Let us now install it and see how it would look once we are done with that. So let's quit this. Let me clear my screen. Let us now install Kivy framework. To do that, I would be typing conda install Kivy followed by -c, then conda forge. Once you're done with this, hit enter. All right, as you can see that we have successfully installed our Kivy library. So let us first clear our screen. Just to cross verify if we have installed Kivy or not, let us jump to our shell. So Python, hit enter. So let us import our Kivy now. Kivy. As you can see here, we are not getting that error, right? File not found error. So this means that we have successfully installed our Kivy library on our system. Now that we have installed Python Kivy on our system, let us now create a simple hello world application that would return us some text. To do that, I would be moving to my code editor. Here, the code editor that I'm using is VS Code. You can use any code editor of your choice, but here I'm going to use a Visual Studio Code. Let us create a new file here, and we'll save this file as demo program1, demo underscore program underscore 1, and then we'll give our extension as .py, and then we'll hit save. All right, so now we have our demo program set up. We'll have to create a class here. So class, we can give any class name. I'll be giving it as demo app. This will be inheriting from the app class. All right, this app class is present in kivy.app module. So from kivy.app import app. All right, this app class is referred to as the main class. Here we'll be having a build method, def build, which would return a widget, right? Return widget. The widget that we'll be returning here is label. So label. This label widget is present in kivy.ux package. So we are supposed to import that. So from kivy.ux.label, import label. Okay, so we have imported our label class. So to give the text that we want, we have this argument called as text is equal to hello world. As we know, this build method returns the widget, right? But in order to run our application, we need to have a run method called. So in order to call a run method, we need to create the instance of this class. Or I can say we need to create the instance of our main class. To do that, we'll have demo, which is nothing but we'll be creating our instance demo app. So now we'll be calling the run method. So demo dot run. Now let us execute our code. So yeah, so as you can see here that we have created our first application. Just to give you a better understanding of Kivy lifecycle, let me now explain to you how Kivy works, okay? So basically what's happening here is every time a run method is called, it creates this particular window. So run method is basically like it's giving us a container. So within the container, we obviously have to fill something, right? So it is the responsibility of the build method to organize various types of widgets and present it well inside the container. So this hello world is basically a widget. So this is presented within the layout, and this is a widget. So this is what I meant by Kivy lifecycle. So the event handlers like on start, on stop, on pause, these are the event handler which are run in the background. So we do not have to call this. It is a Kivy engine that will run that explicitly. Now that we have developed our first application, let us now understand what are the various types of widgets and other UI elements that are provided in Kivy. So we'll start off with understanding what are widgets. Well, widgets in general play a key role in any GUI development. This is because widgets act as an interface or the mediator between the end user and the backend computer program. So what happens with widget is that the end user doesn't have to manually type a code just to get a particular task done. Similarly, in Kivy, widgets play a key role. They act as the building blocks of the Kivy GUI experience. So let us get in detail with this. Here, widgets usually have this event. The event can be with clicking a button or hovering a mouse over it or anything. So every time an event acts on the widget, an appropriate response is given to it. So there are various ways that we can define events, right? So in Kivy, we have two ways. One is a property event, and the second type is a widget defined event. So what happens in property event is that changing in any physical property to the widget, like be it changing the size or the shape or even the position, can cause an event to be triggered. And the second type is a widget defined event. In this widget defined event, the action is pretty specific. So usually we have a callback function which would be bind to the particular widget. And only when a certain type of action is performed on the widget, the callback function is called. So before we move on and look at various types of widgets, let us understand layouts. Well, layouts in Kivy are considered as containers. So what I'm trying to say here is we have this application window, right? Within the application window, we'll have layouts. And within the layouts, we'll have particular widgets in order to beautify our application. In short, what I'm trying to say here is using layouts, we can organize and arrange our widgets according to our needs and customers' demand. So in Kivy, we have various types of layouts, such as anchor layout, float layout, grid layout, and page layout. Let us now look at each one of them in detail. So let us start off with anchor layout. In anchor layout, widgets can be placed either at the center of the application window or at the corners. So the corners can be top left corner, top right corner, or any other corner of the application window. We can change the position or the location of a widget by using anchor underscore X and anchor underscore Y parameters. Let us now move to our code editor and see how to implement our anchor layout. So let us create a new file and save it as demo program 2. All right, so let's save it. So as we know the drill, first we'll be creating a class. We'll give the name of the class as demo application. All right, so this will be inheriting from the app class. Okay, as we all know, this app class is present in kivy.app package. So let us import that from kivy.app, import app class. So this app class will have a build method. So def build and then self. So as we all know, this build method is something that would return the widget, right? So within this build method, let us now define our layout, which will have a button in it. So it would look something like this. So we'll have our window, right? Application window. So within that window, we'll define our layout, wherein initially our widget would be in the center. Then we shall move our widget from center to this particular end, so top left corner. So let's get on to it. Okay, so for this, we need to call the anchor layout class. So that is present in kivy.uix package. So here, let's do that first from kivy.uix.anchor layout. Okay, import anchor layout. So now coming down here, let us call our anchor layout here, anchor layout, and then we'll have an instance of anchor layout stored in layout. Okay, as I've explained earlier, layout is just like a container. So within a container, we'll have widgets. So just to demonstrate that, we'll be calling a button widget here. We'll be adding a button. So button, which is also another class. So we need to import this from kivy.uix. So from kivy.uix.button, import button. Yeah, button class. Let us give some attributes to this button. So text. So text is equal to anchor layout demo. We can give here anything as you desire. So, but I will be giving here as anchor layout demo, anchor layout demo. So let's give a size to this. If you don't give a size, then our entire layout would be covered with this. So size can be defined using size int parameter. So that is again 0.2 comma 0.2. We need to separate them using the comma, or make sure you don't forget that. And then we'll give a background color here, background color. So here you can give any random value. So here I would just be giving it as like 0.0, just a random value, RGB values. So 25, 86, and then over here it is good as 1. And now let's have color of our text to be black, 0, 0, 0, 1. So the 1 at the end is there for the transparency, all right? So now we have this button. We need to add this button to our anchor layout. So to do that, the anchor layout class will have add widget method, right? So here we'll have the instance of our anchor layout. So that's layout dot add widget method. So we use this add widget method to add any widget to our layout. Okay. So add widget. So here we need to add button. So just to make it simpler, let's create an instance of a button. So let's give it as button 1. So let us add this button over here, button 1. Okay. All right, then this is all there is to it. So let us run our application. To do that, we need to call the instance of our demo app or the main class app, and then we'll call the run method. Here we are supposed to return it. So return layout. So here, as we all know, the responsibility of the build method is to return us the layout or to return the main root widget. All right then, so let us now execute our code and see how it looks like. Okay, so let me execute it. So as you can see here, we have this window screen, right? Like which is returned only when the run method is called. So within our application window, we have the layout. And at the center of our layout is our button that we have defined. As I've mentioned in our description earlier, we can position our anchor layout at either of the corners, right? Let us see how to implement that. To do that, we have to go to our anchor layout and define anchor underscore x underscore x. Let's give this at the left, so left. So and then we'll have anchor underscore y parameter, anchor underscore y. Okay, and we'll give this at, let us take it as top. Okay, so now let us run our application and see if the position of our widget changes or not. So let us close this first. Well, then as you can see here that we have moved our button widget from the center to the top left corner here. Similarly, we can move our widget anywhere. We can move it at any of the corners or even place it at this particular part of our window. So moving on next, let us now see what is grid layout. As you can see from the image here, in grid layout, we are arranging our application widgets in the form of matrix of rows and columns. So it is very essential over here that we have to define number of rows and columns. If we don't define our rows and columns, by default we'll have only one row and one column. If you see from the application here, we have 2 columns and 4 rows. So now let us move to our code editor and see how to implement this. So now let us create a new file and save it, demo program 3.py. Make sure you don't forget the .py extension. All right, so let's save this. We'll have a class. We can give this as any name. So here I would be just giving us demo app. So this will be inheriting from the app class. This app class is present in Kivy.app package. So Kivy.from Kivy.app import app. Now this will have a build method. So def build self. So here we'll be defining our grid layout outside the demo app, or I should say we'll be defining our grid layout outside the demo app, and then we'll call the instance of the demo app in the build method. So here we'll return, and this will be returning as the instance of our grid layout. So we'll create a class here. Here we'll give the name here as grid layout demo. So this will be inheriting from grid layout class. So this grid layout is present in Kivy.ux package. So from kivy.ux.grid layout import grid layout. All right. So now let us call its constructor def underscore underscore init. There will be self and then start star keywords arguments. So you might be wondering, right? So why am I having this star star keyword arguments? So we usually use star star keyword arguments when we don't know the exact number of arguments or constant that we are going to call. So now we'll be calling a super method. So super dot underscore underscore init. So here we are using the super method in order to call all the attributes of the parent class. So here the grid layout is a parent class and grid layout demo is a class that we are defining and it's a child class. As I've mentioned earlier, when we are working with grid layout, it's essential that we define number of rows and columns. So let us define number of rows. So self dot rows. So number of rows that we want to be here, let us take it as 2. All right. And number of columns will be 2 again. Self dot columns. Yeah. Let it be 2, or let us take it as 1. Okay, so our application, let me just give you a rough sketch of how I want our application to look like. So we'll have this application window. So within the application window is the grid layout. Okay, or here as you can see we are defining 2 rows, so it would be like basically 2 rows and 1 column. But and if we define here instead of 1, if it is 2, so here it would be 2 columns. It would look something like this. So here we'll be having 1 column. So here we'll design our layout in such a manner that on top we'll have a label and in the bottom we'll keep a button, right? To do that, let us call our button and layout class. So from Kivy.uix, we need to call our button. So let us import our button. Okay, and then from Kivy.uix.label, import label class. Now that we have button and label, first we want a label, right? So to do that, we'll have this L1, which stands for label. Then we have a label class. The text here would be something like, please click the button. And now, as I've mentioned earlier, we need to add this label to our grid layout. Okay, so label is a widget, grid layout is a layout. So to add that, we'll have self dot add widget. So for this, we'll be doing self dot L1. So all right, so now let us add self dot L1. So far, so good. Let us run this code till here to see how it looks. So before we do that, we need to return the instance of our grid layout demo here. So now we'll create an instance of our demo class. So demo, all right, and then call the run method. So now let us run our code and see how it looks like. Well, as you can see here, we have this window here, all right, application window, and then there is this label, please click the button, okay? Now let us add button, which would be just below it. So let's close our application here. So to add our button, all we are gonna do is, we'll define a button here, self dot, that would be, let's give a button as B1 is equal to button class. So let us give some values over here. Text here would be click me. And let us give another property like background color. So here we'll pass a tuple, so which would have the RGB values, right? So we want it to be 0, and then we'll just pass a random values like 24, and then let's give it as 67. All right. We have to also define the transparency, so let's give it as a full transparency. And this defines the background color of the button. Let us also define the text color. Okay, so text color can be defined using color. So this would be equal to, again, we'll pass a tuple. We want it to be black. So it would be 0, 0, 0, 1. Okay. Now that we have defined our button, let us add this to our widget. So self dot add widget, self dot button one. Okay. All right, then now let us run our program and see how it looks like. As you can see here that on top we have our label which says please click the button. On the bottom we have this button widget, so which says click me. Similarly, we can add n number of rows and columns. We use this grid layout usually when the position of our application doesn't play a major role. Moving ahead, let us now discuss what is a float layout. Well, float layout is a most commonly type of layout that is used for mobile application development. Here the position of a widget changes with accordance to the size of our application window. And we have a total freedom here to define the size and shape of a widget anywhere in our application window. So let us now move on to our code editor and see how do we implement this. Let us now create a file and save it. Okay. All right then. So to do this, first we'll be creating a class. Okay. So class demo app. Okay, which will be extending from app class. So this will have a build method. And this build method will return us the widget, right? So now let us import our app class. Okay, so from Kivy.app import app. We'll also import our float layout. So from Kivy.uix.float layout. So import float layout class. So we'll also import buttons here from Kivy.uix.button import button. All right, so button class is imported here. So we'll here first create a class float layout demo. So this will be inheriting from the float layout class. Okay, so float layout. We'll have a constructor here. So def underscore underscore init. with self and keyword arguments. And then we'll have this super method. It'll have an argument as keywords. Okay. Here we'll be creating our application in such a manner that this would be our application window. And then we'll have a button here. Size of the button is not restricted. So we'll define our own button. So let us take a large button here. And then we'll also define another small button somewhere at the opposite end. All right. So this would be our layout, float layout. And within that, we'll have two buttons. So let's try and implement this. So first off, let us define our button here. So button one, so we'll have a button class and a couple of arguments that we would give. So text is equal to button. All right. So now let us add our button to our float layout, self.add widget. So this would be added to our self layout. So self.button1. Let us try to run this app so far. So let us create an instance of our float layout demo and then call our run method. So here we'll create an object of our demo app and then call the run method. So let us run our application now. So as you can see here that we have this button here, which we have defined, and it has taken the entire space. So the default location and position of the widget inside the float layout is at this particular corner. This would be the default position, and the default size would be the size that would fit the entire root widget. Okay, so let's change that. First, let us change our size. Let's close this off first. To modify the size, we have something called as size hint parameter. Okay, so size underscore hint, and this is basically a tuple, and let us give it as 40%. So this is basically like a percent value. So 0.4 means it's a 40% of the entire size of the application window. Along the x-axis, we want it to be 40% of the total length of the application window, and the same along y-axis. Okay, so now let us execute our code once again. So as I mentioned earlier, the default location would be at the corner. Okay, so now let us move our widget from this point to somewhere over here. All right, so to do that, we use this parameter called as position hint. So all right, so this would be basically a dictionary here, and we have to give how far we want our application to be from the x-axis and the y-axis. Okay, origin of the x-axis and y-axis. So here we'll give, so from x-axis we want it to be like 30% far, right? So we'd give 0.3, and then we want it to be like 20% from the origin of the y-axis. So 0.2 here again, 0.2. So now let us run our code and see how our application window would look like. Okay, so running our code. As you can see here, we have moved our location of our widget. So let me now just show you how it is actually. So this is basically the origin of x-axis and y-axis. So if you are giving a position to be like, as we have given here, like 30%, so it means 30% from here. So it would be somewhere here. And this is 20% of the entire length. So that's why y-axis would be somewhere here. So therefore, if you plot our graph, it would come somewhere to be here. All right. So this is the reason why our button widget is placed at this particular location. Now let us implement one more button and see how that would look like. So let us close our application window here and create another button. So self dot button 2. Okay, so we'll have a button class here, and the text here we'll give it as button 2. Okay, we'll give this as a smaller size. So size underscore hint. As we know, this is a tuple. So we want it to be like just 1% of or 10% of our actual window size, 0.1, 0.1. Okay, let's make it as rather than a square, let's make it as a rectangle. So 0.1, 0.2, and then we'll have a position hint here. Okay, so as we know, this is a dictionary, and here let's give a x-axis. So we want to position our this second widget in such a manner that it is like 90% far away from the origin. So for that would be like 0.9, and the y-axis over here would be like, let it be like 0.9. Okay, so it's totally at the extreme end. And now let us run our code and see how it would look like. Yeah, before we do that, we are supposed to add a button 2 to our float layout. To do that, self dot add widget, and then self dot button 2. All right then. So now let us run our code and see how our widget would look like. We have placed the second widget in such a manner that it is 90% away from the origin. Similarly, it is 90% away from the y-axis, the origin of the y-axis. All right. Now that we understood how the positioning works in the float layout, let us try to rearrange this over here. So to do that, all we'll do is I will change it to 80%. Okay, and let us bring this down a bit. So we'll give it as 70. Let us now rerun our program. Well, then as you can see here, we have repositioned our button to our desired location. This is how we implement float layout. So now coming down to the last type of layout, that is the page layout. We use page layout whenever our application requires us to use multiple screens. Okay. So what happens in the page layout is that there are multiple screens, and on top of that multiple screens, we stack our widgets. So the key thing about page layout is that it does not allow us to manipulate the size and position of that particular page. So now let us move on to our code editor and see how we implement our page layout. So now let us create a new file. So we'll give it as demo program 5 and save it. So by now you should be knowing our drill. We'll be first creating our class demo app, which will be inheriting from the app class. All right. So now this will have a build method self, which would return us the widget, right? Return, and we'll give this name later. Okay. So now the first thing that we would be doing here is create import app class. So from kivy.app, import app class. So now that we'll be implementing page layout, so let us call a page layout here. So from import page layout, okay. We'll be needing a couple of widgets. So here that I would be using here is button. So kivy.uix.button. So import button class. So now let us have a class, give it a name. So this will be inheriting from page layout class. So we'll define our constructor here, def underscore underscore init, self, and keyword arguments. After this, we'll be having a super method here, super, and then calling the parent class constructor, and then we'll be passing keyword argument. So here we'll design our application in such a manner that first we'll have our application window, right? So this would be our application window. Here we'll define 3 pages such that we'll have a page 1, and then we'll have a page 2. This will be page 1, then we'll have a page 2, and then we'll have a page 3. Just for the simplicity's sake, we'll have only 3 pages, and the only widget that I would be using here is button. So the key thing that I would like to add over here is every time you add a widget to the page layout, a new page is added up. So let's get on to it. So we'll have button here, bttn1. Obviously we have to give self.button, which would be equal to button class. Just give a random text here, button1. So now let us add this to our page layout. So self.add widget followed by self.button1. Okay. So let us create 3 more buttons. To do that, I'll just be copy pasting this same button definition and adding the button to the layout. Yeah, so this is our second button, and here comes the third button. Okay, so let us align them. And we'll be changing the names over here. So this would be our button 2, adding to button 2, and self.add button 2. So here we want it to be button 3. Change the name to button 3, and add button 3 to the layout. So as you can see here, we have defined three separate buttons. And for each of these separate buttons, we'll be having separate pages. Okay. So let us execute our code. But before that, we're supposed to create object for this. So, and then call the run method for the main class. Okay. So what is the name here? Page layout, right? So page layout. Okay. So we create the instance of page layout here. And then now let us call the run method by creating instance of our main class. So demo app, and then call the run method. As we're all set, let us now execute our program. As you can see here that we have three separate buttons, right? So this is button 1, button 2, and button 3. As I mentioned earlier, every time you add a widget to the page layout, it creates a new page. Now, in order to change our pages, all we need to do here is swipe from either left side or the right side. So yes, this is how we implement page layout in our application. Now that we know how layouts work here, let us now try to understand what are the various types of UI elements that we can implement in our layouts. Fact about widgets are that they are customizable at every level. So what I mean by this particular statement is that in Kivy, we can change the position, size, color, or any feature of the widget at our own will. Apart from that, the responsibility of a widget is to take an appropriate input from the end user and provide a response to it. Kivy provides support for various types of widgets. Few of them are label widget, text input widget, pop-up widget, button widget, and image widget. We should understand each of these widgets by implementing them in our program. So let us move to our code editor. Let us now create a page and save it like demo program 6, right? So before we begin, I would like to illustrate to you how our application would look like. So let us now create a simple diagram to get a better insight of what we'll be creating. So we'll be using a grid layout because it's pretty easier to implement. And the number of columns that we'll be using is 1. And first off, we'll be discussing what is images, how to use image widget. Then we'll understand what are label widgets. And then we'll be taking a look at what are the various ways that we can take the input from the end user. So this is called as text input. And then we'll be having a button here. Why we're gonna have two buttons here is we'll be displaying an image here, and the end user will be asked to choose the right answer. So button 1 would be having one answer and the button 2 will be having the other option. And whatever the answer is, we will be giving them in the form of a pop-up widget. All right, let us now try implementing this in our program. As I have mentioned earlier that we would be using grid layout, right? So first off, let's create a class. We can give any name as we want. So I'll be giving it as demo app, which is inheriting from the app class. Okay, this will have a build method with a self argument here, which would return the widget. All right. Okay, so the first off, let us import our app class from Kivy.app import app. The layout that we are going to use is grid layout. So let us import our grid layout. So from Kivy.uix.grid layout, import grid layout. As we are going to use buttons, so let us call our buttons here. Kivy.uix.button, import button class. Similarly for text input, text input. All right, next for the label from Kivy UIX dot label, import label class. Finally, we'll be importing a pop-up widget from Kivy dot UIX dot pop-up. So import pop-up class. All right then. So now that we have imported the classes that we need, so let's create our own class here. Class Kivy widgets, or we can give it as Kivy UI elements, right? Kivy UI, which would be inheriting from grid layout. So we'll have a constructor here, followed by keyword arguments, calling the superclass constructor or the parent class constructor. So for that, super followed by keyword arguments. All right. So as this is a grid layout, right? So we'll be having the number of column that we're going to use is one. So self dot column. So this should be one. We'll define number of rows later, but as of now, let us keep it as 4. Okay. Self dot rows is equal to 4. Let us now discuss image widget. In order to use images in our application, we use something called as image widget. Image widget is present in Kivy.uix. So let us import that. So from Kivy.uix.image, import images. If the source of our image is our PC, then we would be using image class. Meanwhile, if the source of our image is from the web, we'll be using async image. Here we're gonna here we already have the image, so we would be using image from our system. To do that, all we're gonna do is create an image class instance first. Img will be equal to image class, and the argument that we'll be passing here is source. Okay, we'll take an image here. Okay, copy the path and just paste it here. As this image is present in the same directory, we don't have to give the entire path, just the name of the image would do fine. Now let us add our image to our grid layout. To do that, self.add widget, and then this will be self.image. Perfect. So far we have added image to our grid layout. Let us run our program and see how it would look like. So before that, let us create an instance of Kivy UI class here. So this would return Kivy UI class, and then create the instance of our main demo app so that we can call our run method. So demo app dot run. Now let us execute our code. So as you can see here that we have added image to our application window. Let us now try adding label. First, let us close our application window here. To do that, all we are going to do is create an instance of our label class, self.label. So here it will be a label. And the attribute that we're going to give here for label is text. And you will be giving here as enter your name. So something about label widget that I would like to add here is we use label widget to display a message to the end user. Any message that is to be conveyed to the end user is done through label widgets. So now let us add our label widget to our grid layout, self.add widget, and here it will be self. After label widget, we want a text input, right? So that the end user can add his name. So to do that, we use the text input widget. So self.text should be txt. This would be equal to text widget here. So text input. Here we have the text, and then so we can also add a couple of other features. One being that we can alter the font size. So font underscore size will be, let us give it as 40. Okay, 40 pixels. Now let us add our text widget to our grid layout, self.add widget to self.text. Okay, so far so good. Let us now try executing our program. As you can see here, the first widget that we have added is the images, and the second one is the label widget, and the third one is the text input. Now let us have one more widget here, which would be a button, which when clicked, whatever the message is being inputted over here on the text input will be displayed on the pop-up window. So let's get on with it. So first off, let us define our button here, self.button. We'll call the button class, and then we'll give an attribute to a button here as text. Submit. As we are using button widget, right? So you might be wondering, what is button widget? Well, button widget is something that is very crucial in order to enhance the user experience. Every widget has its own place, but button widget is something that prevents us from writing multiple lines of code just to do one particular action. So here, button widget will usually be having a callback function. So what this callback function does is whenever a certain type of action is performed on the button, right, that callback function gets triggered and therefore giving out a desired output. So here the button widget will be defined in such a manner that every time a button is clicked, right, a pop-up widget shows up, which will be displaying the elements of the text input. We'll be giving here text as submit, and we'll add this button widget to our grid layout. So self.add widget to grid layout, self.button here. All right, that's great now. So let us now create a pop-up widget. To do that, we'll be having self.pop. So this will be a pop-up widget. Pop-up widget is basically a window that pops up on top of the actual parent widget. So we usually use this to display a text or any warning sign to the end user. It has few of the attributes. So one of them being the title. This would be the name of the pop-up widget. So here let's give it as TI title, which would be, let's give the name as pop-up display. If we don't mention the size of a pop-up widget, it would be, the size of this would be something similar to the size of a window. So we don't want that. So let us give a size here. So the size, that is, give it as, so here it's usually a tuple value. So you want it to be 400 pixels cross 400 pixels. What are the contents of the pop-ups? Like, as I mentioned before, every time a button is clicked, we want pop-up widget to display the name that is given in the text input, right? In order to access this content of the text input widget, right? That is, what I mean by this is this text part. All we need to do is call the instance of the text input followed by dot text. All right, let's see how we implement that. So first off, we'll go to a pop-up class. Here we'll be having something called as content. So this content attribute is used to define whatever the content that goes into our pop-up window, right? So which is nothing but we want a label. So as we know, label is used to display the message to the output. And one of the attribute of the label is a text. So we'll give the text to be null now. So this is how we define our pop-up window. So now if we try to run this, we won't be seeing this pop-up window, because in order to call the pop-up window, some kind of action should be performed on it. So to do that, we'll be creating a callback function for our button in such a manner that every time a button gets clicked, we get this pop-up function. To do that, let's create a method here, or a function. So def, we'll give the name here as callback. And then this will have an argument as self, and then elements. So now what we want from this function is every time it's clicked, right? So it should update the value of our pop-up. At the same time, it should also open. In order to update the value, all we need to do is we need to call this class here, self.pop, and then call the contents of the pop-up widget. So that will be content, which is a text value, text. So the content of this over here will be equal to the content of the text input over here. Let us do that by equating the content of the pop-up to the text input content. So it would be self dot, so txt dot text. This particular line of code will copy the content which is present in the text input box to our pop-up window. Okay, and now we'll have self dot pop-up. So in order to open our pop-up widget, all we need to do is use open. Okay, open method. So this is our callback function. In order to use this callback function, we're supposed to bind it with our button widget. To do that, what we'll be doing here is, so self.button, we'll use a bind method. So, and the event that would be is on press. So every time we click, so when it clicks, it will be calling this function. Okay, so it would be self.callback. So now that we are done designing our application, let us now run it and see how it would look like. As you can see here that we have successfully implemented our button widget here. Just a quick recap. Initially, we had defined 4 rows for this. So one row being for the image, second one for the label, the third one for the text input, and the fourth one was for the button, right? So every time we click this button, what happens is we'll have a pop-up window over here, which would display the name that you'd be providing here at the text input area. So let's see whether this works or not. Here the application is asking me to add my name. So let me add my name here. So my name is Junaid, and let me submit this. So as you can see here, every time I submit, we have a pop-up window that displays Junaid. All right. So this is how we implement various types of widgets in Kivy. Up until this point, we have been adding widgets to our application using Python code. Although this is acceptable and works totally fine, but there is much easier and nicer way to do this. Kivy provides support for something called as Kivy design language. So you can think of this as something similar to HTML and CSS, where it is responsible for styling and adding elements to our display. But as we all know, HTML and CSS do not handle any logic behind the application. So let us now see how to create an application using Kivy language. To do that, let us move to my code editor and we'll be creating a new file here. So demo program 7. All right, and then hit save. So here we'll be designing our application in such a manner that we'll have this, again, we'll be using a grid layout here. First, we'll be using a label, which will say the name, which will ask you to enter the name. And then there'll be a text input using which the end user can provide input to the system. And then we'll have another label here where it will be asking your age, and yet again another text input here, and followed by a button. So for this, as you can see, we are using a grid layout. We need to define number of columns. So number of columns will be 1, and number of rows that we would be using here will be 1, 2, 3, 4, and 5. So it would be 5. We'll be defining all of this within our .kv file. So let's get started. Let us now create a class. Let's give the class name as my first Kivy app. So this will be inheriting from the app class, and this will have a build method with a self argument, which will return us the widget. Okay, so we'll return this later. Now let us import our app class from kivy.app. Import app class. All right, we'll be using grid layout here. So from kivy.uix.grid layout, import grid layout class. Perfect. So let's have a class here. We'll give the name of the class as demo, which will be inheriting from the grid layout. Earlier, in order to have our widgets, we used to call a constructor and define all the widgets within the constructor, right, for the grid layout. So this time what we'll be doing here is we'll be just writing pass. Instead of writing our widgets or the layout design here in our Python code, we'll be creating a new file called as .kv file. There are a couple of rules to be followed while creating our .kv file. So let's discuss each one of them in detail here. So first off, obviously you need to end the .kv file with extension as .kv. That would be the first and major rule. That's pretty obvious. And the second part of the rule is the characters that we are going to name, like the naming character, should all be in a lowercase. And we cannot put any name there. The name that we are allowed to use is this particular name. Okay, whatever the name is of the main class. So is it my first app in our situation here? Well, no. First off, it should be a lowercase. Okay, so my first app, everything will be in lowercase. And second most important rule is if our name of the class, like the main class name is ending with app, we have to exclude that part. So the name of our Kivy app, Kivy page would be my first.kv, all in lower cases. So let us now create our Kivy file. So let's create a new file here. Okay, so first let's get the name of this. It's my first app, so it's going to be my first. So let's save this as my first.kv. All right, so this would be the name of our .kv file, and we'll hit save. You can see we have defined our .kv file, and we need to add elements to this. In order to add elements here, what we're going to do is, first off, we need to add elements to this particular class, that is the demo class, right? To do that, what we'll be doing here is, first we need to mention the name of the class that we want the elements to be in. So it's demo. As Kivy language is case sensitive, make sure the name is exactly the same. So as D is uppercase and rest of it is in a lowercase, so make sure it's capital D followed by EMO. All right then, so now that's done. So we'll have a semicolon. Indentation here plays a major role. Okay, so once demo is done, give one indent. Okay, and to give indentation, just hit tab once. So as we know that for grid layout, we're supposed to define the columns. So the number of columns that we'll be using here is 1. So instead of equals, we'll be using this semicolon here. So the number of columns is equal to 1. And rows, again, this will be equal to 5. All right. So we have defined number of columns and number of rows. As you can see here from the diagram, the first thing that we have is the label, right? So we'll have a label and we need to add text to our label. Okay, so to do that, so we'll have text followed by colon. So here it will be enter your name. We'll also give another attribute over here. Let's increase our font size. So font underscore size. Let's give it as a 50 pixel. Okay. After the label, we have some, we need to capture the input. To do that, we have text input followed by the text over here. We'll give it as blank. Okay. It's not mandatory for us to provide text as an argument for the text input, but anyways, we'll give here for the reference sake. And we'll increase our font size here by 50 pixels again. Cool then. Similar thing we'll be doing for our age and capturing the age. So let's copy the code here and paste it. Let's make sure our indentation is perfectly fine. All right, so and let's change the question here. Enter your age. So finally, we need to have a button here. To do that, so we'll have button, and the text that we'll be giving here for button is submit. So as you can see here that we have defined all the attributes that would go inside our layout individually using Kivy language. So let us try to execute our program and see how it would look like. So before we do that, let us first create our object for our main class so that we can call the run method. So we have my first app followed by the run method. Apart from that, we also have to create an instance for our demo class. That being said, let us now try to execute our code. As you can see here that we have successfully created our application using Python and Kivy. So let's see what we have done. Just for a quick recap. So here we have defined a single column followed by 5 rows, right? We have added individual widgets to each rows. So let's try to provide an input. So enter your name. So it's Junaid, that's my name, and I'm 24 years old, and let's hit submit. But we haven't defined a callback function for the submit button. As I had mentioned earlier, using Kivy language, we can only use it to display elements on our window. So in order to capture these elements and use it in Python code, we'll be using something called as object property. In order for us to use object property, first we have to import object property. So from kivy.properties, import object property. All right. Once we have imported this object property, we have to do another thing in our .kv file. We have to define global variables. So this global variables is something using which we can access our elements in our .py file. To initiate the global variables, what we're going to do here is, so here we have to give the name, right? So it would be name. All right. So basically these are nothing but key value pairs. This name over here becomes the ID for the text input. So this is unique for every widget. So we would be giving this by ID followed by the name. And we have another text input here which represents age. So let's give the ID for that. So here it's age and then age over here. Text input. So the ID here goes as age. So this is what we're supposed to do in our .kv file. Now coming back to our .py file, in order to capture these elements, what we will be doing here is we'll be using the name that we had defined in our .kv file followed by the object property. So object property, and then the argument that we'll be passing here is none. So this would get us the name and the age and object property. All right. In order to get the display, let us have a callback function. So we'll be defining a callback function in such a manner that every time the end user hits submit, the name would be printed out. So to do that, we'll have def. We can give the name as onClick followed by self. So as we want to print this in our Python, so what we'll be doing here is my name is and I am years old. If we want to pass self.name, keep in mind that after self.name, we're supposed to add text. And the second one is self.age.text. And the second thing that I would like to add to this logic is every time the user hits submit, first off, we want it to be printed on our Python screen or Python terminal. And the second thing is we want to reinitialize the value so that we do not have to press backspace. Okay. So to do that, self.name.text. And similarly here, self.age.text. Now that we have created our callback function, we need to bind this to our button. All right. So here we'll come down to the button and we'll have this attribute called as onPress. Okay, and now we are supposed to call this particular function. Okay, so it's .onClick. Okay, so to do that, we'll have onClick. So we need to have this root .onClick. So let us now try to run our application. So as you can see here that we have this application window where it's asking us to put our name. So it'll be Junaid and I'm 24 years old. So once I hit submit, right? So initially when I hit submit, there was no action performed on it. So now let's see what happens. So let me hit submit. As you can see here that two things have happened. First off is the text elements over here. The text input over here has been reinitialized. And the output part of this you can see over here. So my name is Junaid and I'm 24 years old. Similarly, we can perform this action n number of times and we'll have the similar output. So let's try it again. Let's give the name here as Sam, and Sam here is 18 years old. And then let's hit submit. So you can see here the value has been reinitialized over here, and also the name has changed. So my name is Sam and I'm 18 years old. So this is how you would implement Kivy language and Python language. Now that we have covered all the major concepts that are required for building an application, let us now see how to develop a tic-tac-toe application. So let me move to my code editor. As you can see here, I've already written my code and I would be explaining this to you one by one. So before we start, let me give you a brief description about how I would be developing my application. So here we have two windows. Bear in mind, window is different from screen. All right. So here we have two windows, and then we are going to make use of two pop-up widgets. So in order to control this window, we use something called a screen manager. Okay. Each of these windows are defined under screens. So what I'm trying to say is we have a class and this class would be inheriting from the screen class. Now let us discuss how this program works step by step. In the first stage, the players have to enter their name. So as there are two players, there would be two names here, and then we'll have a submit button. When the end user clicks this button, which is basically for toss, the callback function is designed in such a manner it would randomly choose either one of the player's name and display it on a pop-up. The pop-up window, which is there, it is covered with button. So what happens over here is every time the end user clicks this toss button, the name of the player who has won the toss is displayed on the button. And when the end user clicks the button, right, the pop-up window disappears or closes and then moves to this third particular window. Here, the person who has won the toss will have an option to choose either X or 0. Okay. Once he clicks submit, there would be a grid where they can put either X or 0 values. Whenever there is an optimal outcome, be it draw, be it a win, a player who has won, once there is an optimal result, all the buttons would be disengaged or disabled and a pop-up appears showing whether the player has won or it's a draw. So now let us go back to our program and see how we have implemented this using our code. So as you can see here, I have saved this particular file as main.py. The first off, we have imported all the classes that we would be using here. Okay, you can see here there is a mixture of widgets as well as the layouts. In the first class here, we are defining the first pop-up. So as I have mentioned earlier, the responsibility of the first pop-up is to show which player has won the toss. Okay, so this is a pop-up widget, so which is inheriting from the pop-up class. The entire pop-up window is a button. Thus it has a press me here. Every time the button is pressed, the pop-up close. Therefore, this is the callback function for it. So in order to close the pop-up, we use self.dismiss. As I had said earlier in our tutorial, if we do not specify the pop-up size, it would occupy the entire window. Thus, to prevent that, we are going to define our pop-up window size, and the title of our pop-up window would be toss. So here in this class, we'll be defining the pop-up widget for the second pop-up. So as we all know, the second pop-up is responsible for showing the result, right? So because of that, I have given my title of my pop-up as result. And there is this press button to dismiss the pop-up. Apart from that, we have mentioned here what would be the size of our pop-up window. So as you can see here that I'm adding this to this L2 class and not to any other class. We'll see why I'm adding this to the L2 class. So coming down to our first window, here as I had mentioned earlier that we are going to use multiple screens, we'll be having this class which is inheriting from the screen class. In order to obtain all the properties which are written in Kivy, we are going to make use of object property. So moving ahead, here we have this function show now. This function is basically a callback function wherein every time a person hits the toss, a random number gets generated in order to give person who has won. As you can see here in this particular pop-up open, this pop-up function is used to display the player who has won the toss. Tab2 class is where we are going to define our second window. We'll be storing our options either X or 0 in a list here. The reason why I'm doing this here is because we can alternatively change the values. If it's X once and the next trial would be, obviously in the next step it would be 0, right? So I'm going to do that using this. Self.padding is used to create a small gap between two widgets. As we are going to use grid layout, we are going to define number of rows and columns that we'll be having. Moving on, this is where we are going to define the logic for our program. So every time the program runs, the user has to put either X or 0. Anything else apart from that, all the buttons would be disabled. He can put either in upper or lowercase x. So as you can see here, the end user has to put the input as X or 0. This is where we are going to capture our text. And there would be a small spacing that I'm going to provide here with 5 pixels, okay? As you can see here, within the grid layout, we're going to have multiple buttons so that the user can play. So the first button would be for the submit button, and the rest of the buttons over here are for playing the game. So these are the buttons that are initialized and binded and then added to this particular widget. So now let us move on and see what is the logic behind every button. As you can see here, in this callback function, if the person or if the end user doesn't provide a proper input, that is either X or 0, it will be first off disabled, all right? And the second thing here is, if the input that is provided is correct, all right, there's a counter which increments, and then we have this particular value here. If the previous input was 1 and the next input would be 0, indicating that it is either X or 0 values. Once the user has clicked the button, it would be disabled. I'm going to use this print pressed just as we are developers and we want it to appear on our screen to test our code. This is how every button would work, and similarly we have defined for the rest of the buttons. In this def.result function here, this is where we are going to see if the particular input that has been added in the grid is a valid one or not. What I'm trying to say here is, if this is the grid here and each one of these are buttons, right? So now this result function is defined in such a manner that if the values of the buttons are already X, X and X, then it is considered as that the X is the winner. Similarly, it's done for the Y. And the rest of the if else conditions are here to predict all the possible outcomes. So let us now have a quick look at this. So if the button X and X, if they are all true, then yes, obviously X becomes the winner and then the button gets deactivated. Similarly, I've done it for all the 9 buttons. Coming to the end of this program, you'll see that I have used something called as a screen manager. Well, when we are dealing with multiple screens, we use screen manager class. And screen manager class handles the various screens. In order to do that, we'll be having this class wherein we have the widget inherit from the screen class, as you can see here. So coming down to our main class, so we have this build method. We can add the title to our application window using self.title attribute. And then we can also add icon to our application using self.icon attribute. This function would return a widget. And in order to run our entire application, we would be using myRootApp.run. A quick thing to note, now here I have mentioned our screen one, right? Like this is a screen window class. And the screen window class is adding the tab 2. On the other hand, I have displayed my first screen in .kivy file. So as you can see here, I'm going to use a grid layout, and the grid layout will have two label and two text input, each of it for two different players. And the second grid will have the button, which when pressed performs multiple operations here. So let us now execute our program and see how it looks. Okay, as you can see here, we have player 1 and player 2. This is basically a grid layout, and we have defined this part of the code in .kb file. As we provide the input here, so let it be Sam and Ram, and then let us hit a toss button. As I mentioned earlier, every time I click a toss button, a pop-up appears, which is actually a button. It says that Ram has won the toss, and I'm supposed to click this button to start. So as you can see here, the pop-up has disappeared. And now over here, I've provided with the text input wherein it says choose either X or 0. So let me choose X and then hit enter. As you can see here that this button, once I give a proper input, has been disabled. And now let us play the game. So if the user tries to put X over here, what happens is the counter increments, and therefore the value in the index position will change. So the next output here would be 0. Again, the value has changed back to 1. Therefore, the value in the list at index 0 would be X. All right. Similarly, it's done for every button here. If there is any winner, there's a pop-up that shows 0 is the winner. And as you can see here, every time there's a winner, right, the button gets disabled. This was a simple application which can be built using Kivy. So now that we have successfully created our application, let us move to our terminal and build our own APK file just so that we can run it on our mobile. All right, as we come down here to our Linux virtual box, the first thing that you got to do is get all the project file over here. You can do this by using either GitHub command or by copy pasting your project folder using a pen drive. Now you might be wondering, right? So why did we change our operating system? So the reason for that is in order for us to build the Android APK, we need a tool called as Buildozer. And the Buildozer can be run only on Linux terminal. So because of this, what we are going to do is we're going to import all our project files from our Windows operating system to our Linux. Then we'll be installing our Buildozer. And then there are a couple of dependencies which we will be seeing that on the Buildozer official documentation. In order to create our APK, we just have to write 2 lines of code. I have to open my files here. You will see that I have imported all my project files over here. So now let's get to our browser and see the official documentation. So before you try to create an Android APK, we need to install this Buildozer. To do that, just type pip3 install --user --upgrade Buildozer. After that, you need to install a couple of dependencies that come along with it. As I've already installed Buildozer in my system, let me now show you how to create the Android APK. So going to my terminal, I'll be getting into the folder where my project files are present. So that would be cd. This is the folder, and I'll hit enter. In order to run the Buildozer, we have this command called as buildozer init. What this buildozer init does is it will create .spec file. So let's try doing that. So buildozer space init, and then hit enter. All right, so as you can see here, the spec file is created. So let's get back to our files. So as you can see, this buildozer.spec file is a new file, right? So this was created only after executing that particular command. So once you're done with this, all we need to do to create our Android APK is buildozer-v Android debug. Okay, so let's try that out. Buildozer-v Android debug space debug. And then let us hit enter. As you can see here, we have successfully created our Android APK. So let's get back to our files. Okay, so now we can see this new folder has been created called as bin, which is right next to this bulldozer.spec. Okay, so as we open this, you will see that we have this Android APK. So now what you're going to do is you're going to take this Android APK file on your Android cell phone, and then make sure you have enabled the developers option on your phone and try installing this. You will see that an application appears just the way you have developed on your desktop. Alright guys, with this we come to end of this session. I hope you enjoyed and learned something new. So if you have any further queries or questions, please do mention them in the comment box below. Until next time, goodbye and take care.
I hope you have enjoyed listening to this video. Please be kind enough to like it, and you can comment any of your doubts and queries, and we will reply them at the earliest. Do look out for more videos in our playlist and subscribe to Edureka channel to learn more. Happy learning!